Concepts again. Introduction to concepts. What point do you introduce a person to the ideas and the concepts of, say, minerals and elements? Those things that make up the very environment, the very thing that's doing this video, the camera and the subject in the camera. So this elements and minerals, what does it matter to us? Where do you introduce children to these ideas, maybe? Well, there's a periodic table. It's part of chemistry that you learn. So where does chemistry come in curriculum time? What age? When is a child's mind kind of ready for the concepts of chemistry and learning about discrete elements that make up the human body, that make up trees that we stare and wonder at in amazement that it works, whether it's mystical, magical, or physics. The tree is still amazing standing on its own. So, elements and minerals, what are these things? Like I said, it's what makes up the real world around us. But what triggered this is I saw another conversation about a new periodic table. The periodic table of elements, we're shown one, the most common one. That's what we're taught and trained to, and it is right and correct in how it presents its information, but there's many other ways to do that. Because the periodic table of elements is an introduction to the concept of elements. The concept of isotopes comes into play after that. These are elements, but they're derivatives of those elements. They're nuances to those elements. They act like those elements or elements around them. They exist in the real world. Some of them have decay properties. They've helped us further understand the age of about everything around us because we can count these minute, tiny little particles where there's a billion particles, a billion atoms on the tip of a needle. That's how large that tiny little needle point is. It's how large we are in that small universe, or how tiny we are in the bigger universe. But that introduces you to the concepts of lots of things going on out here in the world. So where would you pose that next step? Where do isotopes of those elements come in? How abundant are they? What does it matter? Well, as you go on, you're going to hear about things like carbon dating, carbon-12, carbon-14. There's other carbons. You're going to hear about nuclear decay because that's what happens with radioactive, radioisotope materials. They have short lives and they can give off their energies and kill. But not all the time. There are odds, there are statistics around that, and we kind of understand these. But these elements and the isotopes that surround them in massive quantities, we now know, is what life is built from. It is ubiquitous. You also know that some of these isotopes of normal elements never existed before. Never existed, but in theory or in, say, parts of the sun. Parts of the sun we can't venture near, although we can study them well now. So these isotopes, the isotope idea, why does it matter? Because it's real. It's a real part of the world around us. It's part of the sciences that make up the world around us. It's hard to understand if you can't understand time and decay theories, how things rot, even out in the woods. That tree when it falls, that bear when it shits. Those things change over time into something else. They metamorphosize. They magically transform into the food for the next generation of whatever's out in the forest. That's how hard or easy the sciences are, but all the pieces tend to fit together very well. There isn't much of a debate about these. There's a debate about the fine details and points and directions and meanings of these details, but not about the facts of the age of the Earth, the age of the planet itself. These things, big extended things, we have very good ideas about. We're debating the tuning points, not the the artifacts of our studying the world around us. So there you go, concepts, isotopes in the world matter, and now you know.